Preview, please. Preview, please. Come on, work. There we go. Perfect. All right. Good morning. A1 Algebra 2 CP. Happy Tuesday morning. This is May 5th. This is Cinco de Mayo. I don't have any Cinco de Mayo attire, but I do have some Revenge of the 5th attire. I did not see you yesterday on May the 4th, which is Star Wars Day, so I made up for it today. I don't have any Cinco de Mayo attire, though. Otherwise, I would have worn some Cinco de Mayo colors. But in any case, happy Tuesday. Hopefully you're having a fantastic morning. Today, what I would like to do with you is I would like to go through some more topics with you. Specifically today, starting a new topic on now taking a look at the algebraic side of these rational expressions and equations and rational things that we've been talking about. And it really is going to call back to these types of fractions that you've worked with maybe even in elementary school. And maybe it's been a long time since you've just seen a straightforward problem of 2/5 times 3/7. But hopefully today we're going to become masters of not just doing that with regular old numbers, but doing that with x's as well, even throwing in a little bit of factoring and simplifying along the way. All right, so hopefully what I would like you to do is while I'm going through my usual spiel of reminders, please take this time to actually try some of those problems on your own. It'll take about, I'm going to give you about 3 minutes to make sure you try those problems on your own. I don't just want you to stare at them and not attempt them before I start to talk about them. And in the meantime, like I said, as you're trying these problems, I'll just go through some quick reminders for you. Just a reminder, everybody's gotten good at this, and I just love I love that fact because I appreciate that you're so respectful and cooperative, that everybody's having their microphones muted and their webcams disabled. If you do have a question, though, at any point, I do not want you to be afraid to speak up and ask. Please, please, please feel free to just interject, or even if you don't want to interrupt me, like you feel like it's rude to do voice chat, or you have distracting noises in the background, feel free to type it in the chat as well. Just please ask me a question if you have any questions along the way. That's thing number one. Thing number two is the progress assessment that was due on Sunday night. I did grade. The grades are not in Aspen yet. I will get them in Aspen by the end of the day today. I will also post the answer key on Google Classroom. So the idea is that you would check the answer key to see how you did, compare it with your grade on Google Classroom, and if you have any more specific questions or you would like to see any of the other problems done in more specific detail, please, please, please do not hesitate to reach out. Just say, Mr. Giorgio, I'm confused as to why I got such and such a grade. Do you mind going over that? Or, hey, can I meet during office hours to go over a certain problem? That's fine as well. Another thing I want to make sure I remind you of is that the teacher that's working with me for period A6, that's my other Algebra 2 class, is Miss Mao. I've been posting the notes that she's been providing on our Google Classroom page. I think that's really awesome. She also holds a extra help session every day from 1:30 to 2 o'clock. So if you want to go ahead and stop by, the Meet link is on our Google Classroom page. You can stop by. You can ask her any questions. Of course, you can come ask me any questions you want as well, but she's there as well. So I just want to throw that out there as another resource that you can feel free to pursue. All right? All right. Without any further ado, let's go ahead and jump right into problems like this. Now, like I said, it may have been a long time since you were just asked a straightforward simplify problem with multiplying fractions. Hopefully you remember and recall that when multiplying fractions, you don't have to do anything fancy. You don't have to find a least common denominator or anything like that. That will come soon. That will come next class when we start talking about addition and subtraction. But when we're just multiplying and dividing, we just combine the numerators and combine the denominators. Multiply the tops, multiply the bottoms, straight across. So in order to simplify something like 2/5 times 3/7, I would multiply the numerators, 2 times 3, which is 6. I would multiply the denominators, 5 times 7, which is 35. And so you could represent that product as the fraction 6/35. Alrighty? So it's just multiply numerators, multiply denominators. If you can reduce, then you should, but in this case we can't. The second one, though, we will be able to, if you notice. Multiply numerators, multiply denominators. We have 3 times 2, which is 6. Then 4 times 5, which is 20. So that comes down to the fraction 6/20. We can, however, reduce that fraction. We can reduce it both by a factor of 2, because both 6 and 20 share a common factor of 2. So this can reduce now to 6 divided by 2 is 3, 20 divided by 2 is 10, reduces down to 3/10. Okay? typically, in my experience with teaching Algebra 2 CP, everybody with these two problems is like, yeah, obviously, I know how to do that. Maybe it took just a little light refresher, but now it's like, okay, I got it, no problem. Multiplication, multiply the numerators, multiply the denominators. Division, however, seems to be where everybody kind of panics and has this like deer in the headlights look as to like, all right, what do I do? Well, when you divide by a fraction, it's super important. I can't stress it enough because my pre-calculus students struggle with it as well. No offense to pre-calc people, but it's just a common thing that people struggle with. When we have a fraction divided by another fraction, or just when you divide by a fraction in general, you don't panic, you don't cry, you don't freak out. You just multiply by the reciprocal. So I'm going to take 2/5, and instead of dividing by the fraction, I'm going to multiply by the reciprocal. I'm going to do 2/5 times the reciprocal of 3/7. Okay? Does everybody see that? And if you notice, this problem pretty much turns exactly into this problem, because if you notice, it's almost like that was by design, because this is multiplying by the reciprocal. It's 2/5 times 3/7. Here you have 2/5 divided by 7/3. You multiply by the reciprocal, and you'll get the same answer that we got over there of 6/35. Does that make sense? So the big takeaway, and if you can't remember it, then please write it down in your notes. When you divide by a fraction, multiply by the reciprocal. It's the same thing, right? Think about it as dividing by 2 is the same as multiplying by 1/2. When you divide by anything, you can just multiply by its reciprocal. Now, this is another point where students kind of panic and freak out, but really this, which is called a complex fraction, which I'll talk to you a little bit more in detail about today, this is really just this written in a scarier way. Is it not just the fraction of 3/4 divided by the fraction of 2/5? That's exactly what it is. It's just written in a way that makes it look intimidating. But if you feel comfortable with doing that, you could split this apart to say it's 3/4 divided by 2/5, right? You could just rewrite this complex, scary-looking fraction into something that looks a little bit more familiar. Now, just like we did over here, you know that when you divide by a fraction, it's the same as multiplying by the reciprocal. That's going to give us 3/4 times the reciprocal of 5/2. I would multiply this now to get 15. 3 times 5 over 4 times 2, which is 8. So that would be 15/8. Okay? If you get an improper fraction, that's totally fine. You don't have to change that to 1 7/8 or change it to some sort of other mixed number or something like that, a decimal. You just leave it alone, 15/8. Okay? If you feel comfortable, you could certainly choose to skip this intermediate step of rewriting this like this. And you could just say, oh, I'm dividing by a fraction. Let's take this and multiply by the reciprocal. So you could jump right to that bottom step if you feel comfortable. Okay. Does that make sense to everybody how that's done? Hopefully feeling good about that. Okay, hopefully feeling good. All right, so let me just go ahead and show you now a couple of more details about what's called complex fractions. Okay, and then I want to show you actually how that's now going to connect and relate to the problems I'm going to have you practice for our purposes in Algebra 2 CP. All right, so just to talk really quickly about something called a complex fraction. Sort of a misleading name in my opinion, because a complex fraction, I've also heard them called compound fractions. A complex fraction, you would think it has to do with complex numbers, which is I, but it actually doesn't, which is weird. A complex fraction is just when you have a rational expression, so a fraction, containing a fraction. In other words, it's like when you have something like number 4. That would definitely be a complex fraction. It's a fraction that has fractions in it. It's a rational expression that has fractions in it. So it's a fraction divided by a fraction. All right? Look at specific cases when you're dealing with complex fractions. Okay? Just a couple things to consider. If you have a over b for any numbers a and b, all divided by c, right? Suppose I have a complex fraction that looks like that. Well, in order to simplify something that looks like that, what I can do is I can rewrite that as if we're dividing everything by c, then just like before, we can really say that's multiplying by the reciprocal. Can't we write this a over b divided by c? We could say that that's a over b times 1 over c. Think about it. If we're dividing everything by c, we're really multiplying by 1 over c. Think of if you're dividing by 2, you would really be the same as multiplying by 1/2. And so this will simplify down to a over b times c. Okay, that's good to know as far as complex fractions are concerned. All right, consider a concrete example. Suppose I'll show you some actual numbers. If I have 2/3 divided by 5, right, what would that actually look like? Well, we can go ahead and rewrite something like that as 2/3 times 1 over 5, because that's really what's going on. You're just breaking it apart. And then we could simplify that down to 2 times 1 is 2, and 3 times 5 is 15. So that would be 2 over 15. Okay? So important to understand how to work with expressions that look like that. I guess that's the big takeaway. It's important to, if you encounter something like this, not freeze and panic and not know what to do. It's important that you're able to work with something like that. All right, let's take a look at something else. What if I have sort of the inverse of that? I have a divided by b divided by c. Okay, so I have one number on the top and then divided by a fraction on the bottom. Well, I'm really going to do what I kind of did before. When I divided by a fraction, what did I do up here? I multiplied by the reciprocal, and that's exactly what I'm going to do. I'm going to say that this is a over 1, you could really write it as a over 1, times the reciprocal. I can say that's c over b. Okay, and this would really simplify down to, in general, a times c over b. Okay, taking a look at another example with some concrete numbers. If I said let's have kind of a similar problem as to what we just did. Let's say we did 5 divided by 2/3. Okay, notice that's a fraction that contains another fraction. Not scary though, we just take that and we multiply by the reciprocal. I'm going to do 5 times the reciprocal, 3 over 2, and I would get that that's 15 over 2. Does that make sense to everybody, how we're working with these complex fractions? This is sort of background information, just FYI, as to what we're going to be moving into in the last 15 minutes of class. One more example is just like we saw up here. What if you have a full fraction divided by another full fraction? So say I have a over b, the fraction, divided by another fraction, c over d. Okay, I have a over b divided by c over d. One fraction divided by another fraction. Again, that doesn't mean we panic and freak out. We just multiply by the reciprocal. That's like the mantra. When you divide by a fraction, just multiply by the reciprocal. So I'm going to change this to a over b times the reciprocal of d over c, and this becomes ad over bc. Okay, take a look again at another concrete example. If I have 5/7 all divided by 3/4. Okay, something like that. We're right at the bottom of the screen, but still good. I'm not going to panic. I'm not going to cry about that. I'm going to say this is a fraction divided by a fraction. So I'm going to take this fraction and multiply by the reciprocal. I'm going to do 5/7 times the reciprocal of 3/4, which is 4/3. And so I'd write that as 5 times 4 is 20, and 7 times 3 is 21. Okay, so that would be the fraction 20 over 21. All right, I feel like even though I've said it a lot, I want to make sure I write it. If when you divide by a fraction, multiply by the reciprocal. Okay, can't stress that enough. Very, very important. All right. So that's just a little bit of background knowledge as to getting into the next skill that I really want to go through with you, which is simplifying rational expressions. So far, we've really just worked with numbers, regular old numbers. Now, let's see what happens when we introduce a little bit of variables and a little bit of factoring into these types of things. First, though, I'll give an opportunity for questions. Does anybody have a question as to any of these problems and any of these concepts that I guess that we've talked about so far? Questions? No questions? We're feeling good? Alrighty. I take your silence as, Mr. Giorgio, we are doing just dandy on this Tuesday morning. Alright, fantastic. So, let's go ahead and actually look at some examples for our Algebra 2 purposes. Ready? What if I gave you this example and I asked you to simplify? We're not solving equations yet. We will be very soon. But we're just simplifying. Simplify this expression. I have 2x minus 10 divided by 3 times 6x minus 24 over x squared minus 9x plus 20. Okay. Well, you might think that we just went from 0 to 60 really, really fast. You might be like, that looks way harder than what we were just doing. And in a sense, you might be right. But what we could do here is, again, hopefully your Algebra 2 instincts are like cluing in as to what to do. You're like going crazy. You're like, Mr. Giorgio, I already know what to do. We have to factor. Of course we have to factor. Because look, we have a greatest common factor over here. We have another greatest common factor over here. We have a trinomial factoring over there. So let's, before we dive into this problem and multiply the numerators and multiply the denominators, just simplify the expression. So in the numerator, top left, I can go ahead and say we have 2x minus 10. We could take out a GCF of 2, and we could rewrite that as x minus 5 all over 3. Everybody sees that, right? How that simplifies down? Times. Notice the bottom left, we can't really do anything with that. 3 is just a regular old number. It stays the same. In the top right, we got 6x minus 24. Let's take out a GCF of 6, giving us x minus 4. All divided by. And now how the heck can we factor something like x squared minus 9x plus 20? Well, break it down into two binomials. I need, let's see, x and x to make x squared. I need both the same sign to multiply to a positive number at the very end. And since it's a negative number in the middle, it makes sense to put minus and minus. And then how can we factor down 20 to combine with 9 when we distribute? How about minus 5 and minus 4? Okay. Now, notice what we get when we multiply all of this stuff together. If I multiply the tops together, I can get 2 times 6, which is 12, times x minus 5 times x minus 4, right? I'm not going to distribute those out because if you notice, there is going to be some cancellation. That's kind of the point of factoring and breaking down like this, so you can see that cancellation occur. But that's what we do. 2 times 6 is 12, and then I'd have my factor of x minus 5 and my factor of x minus 4 in the numerator. In the denominator, I would do 3 times x minus 5 times x minus 4. And then hopefully you're looking at that and you're like, wow, 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 wow. What a happy day. We got x minus 5 in the numerator, x minus 5 in the denominator goes away. X minus 4 in the numerator, x minus 5 in the denominator goes away. I'm left with 12 over 3, which is 4. So that whole big, scary, complicated expression simplifies down to 4. It's pretty cool. Come on, that's got to be at least a little cool. It's got to be at least a little cool. Once again, if you're comfortable with just skipping right from this step to this step, that's absolutely fine. You could just look at this step and you could say, oh, x minus 5 on top, x minus 5 on the bottom. X minus 4 on top, x minus 4 on the bottom, and you would just write as 12 over 3. That's fine too. I just wanted to show you that middle step to really demonstrate what's going on here. Any questions about that? We're going to do one more multiplying, and then we'll go into a division example. Okay, how about something like this? Ready? I'm asking you now to simplify this. We have x to the third plus 7x squared, all divided by 2x squared minus 18x plus 28, looks a little scary, times 2 over x. Okay? Simplify something like that. Well, what you should do at the very first step is, again, you should be drawn to factoring. And hopefully that is the case. At this point in Algebra 2 CP, when you see expressions like that, you're like, there's definitely got to be some factoring. So in the numerator in the top left, we could take out a GCF. That GCF is x squared, leaving me with x plus 7. In the denominator, that's bottom left, first thing I could do is take out a greatest common factor of 2, leaving me with x squared minus 9x plus 14. And I'll revisit that in just a moment. Can't do anything in the top right, can't do anything in the bottom right. All right, let's keep going with this. If I continue, we'll rewrite it up here. We can do now in the top left, we still have our x squared times x plus 7. In the bottom left, I could say this is 2. We could break down that trinomial into two binomials, x and x. How about minus 7 and minus 2? I think we're getting pretty comfortable with that right now, yes? Good, good, good. Very good. Very good. Okay. And then we got times 2 over x. Now, notice what's going to happen here. The reason I wanted to put an x plus 7 and x minus 7, the same problem, is because you may be very tempted to say, ooh, x and then 7, x and then 7. Unfortunately, these are not the same, so we do have to kind of leave them separated. What can happen, though, is the 2 can cancel out with the 2. I'm happy with that. The x can cancel out with one of those x's up there. And so I'd be able to simplify this expression down to x times x plus 7 all over x minus 7 times x minus 2. Okay? It's a little better than what it was before. Okay? If this were an x minus 7 on top, then I could cross out. But it's important to recognize that you can't just like cherry pick. You can't just say, oh, there's an x here and an x here, so I'm just going to cross. That doesn't work that way. And I guess that's a point that I really want to make sure I emphasize. If I have something like x plus 5 over x, or even worse, x plus 5 over 5, we can't just cross out the x's and say that that's 5, or cross out the 5 and say that that's x. That's very, very bad algebra, and that is a common mistake that a lot of students make. Consider it with real numbers. If I had 1 plus 3 all divided by, I don't know, 6, right? That's going to be 1 plus 3 is 4 divided by 6. That's 2/3, right? I can't just say, oh, sorry, let me match up the numbers here. Like 1 plus 3 over 3. That's a great problem. Okay, if I have 1 plus 3 over 3, right? 1 plus 3 is 4. 4 divided by 3 is 4/3. That's 1.3 repeating. I can't just say cross out the 3, and it's 1. That doesn't make sense to me, right? We can't just cherry pick. That's commonly in algebra what's known as the crime of cherry picking, where you're just picking certain parts to cancel out with no actual algebra basis. All right, just to show you another example with real numbers. If I had 5 plus 7 over 7, right? 5 plus 7 is 12 over 7. 12 divided by 7 is a decimal. I certainly can't say, oh, 7 divided by 7 goes away and it's just 5, right? It doesn't work that way. When you have a plus sign here, this is one singular term that cannot be stripped apart. So that's a very, very important takeaway of that. All right? Any questions, comments, or concerns about those multiplying problems? We'll do some division problems next. Okay, let's get into some division problems then. Okay, how about if I have this? Ready? We're going to do x plus 3 divided by x squared plus 2x minus 8, all divided by 12x plus 40 over x squared minus 9. First things first, when I'm dividing by a fraction, no matter how complicated that fraction looks, I first want to multiply by the reciprocal. So that's exactly what I'm going to do. I'm going to change this. Instead of division, I'm going to flip it to the reciprocal, right? Or I guess I didn't mention that. I've been using that word reciprocal. Again, that means to flip. And so I'm going to rewrite this now as x plus 3 over x squared plus 2x minus 8 times the reciprocal. The reciprocal is x squared minus 9 over 12x plus 40. Okay, we just multiplied by the reciprocal. Now I can go ahead and try to factor and simplify and clean up as much as I can. In the top left, I can't really do anything with x plus 3. That's going to stay the same. In the bottom left, x squared plus 2x minus 8, we can break that down to be x, plus 4 and minus 2. Going through that a little fast just for the sake of time, but hopefully we're comfortable with factoring at this point. Over here, we could say, ooh, well, x squared minus 9, is that not just x plus 3 times x minus 3? Why am I thinking that this is like backwards? Because I feel like the x plus 3's were supposed to like cancel out with each other in this problem. I feel like I may have written this backwards. I feel it may have written this backwards because I designed this problem such that the x plus 3's would cancel out, and the way it's written now, that's not going to happen at all. Right. Oh, not 12. Jeez. 4 times 3. All right, let's try it again. Let's erase this problem. Let's redo this. Let's redo this. That's okay. That's okay. Slight setback. Still not an issue. We can overcome adversity. Here we go. Ready? Let's try this again. X plus 3, scratch what just happened. X plus 3 over x squared plus 2x minus 8. Now let's do divided by x squared minus 9 over 12x plus 40. Okay, let's start over. What if I had something like that? What could I do? Well, what I could do is I could go ahead and first change this to multiplying by the reciprocal. We got x plus 3 over x squared plus 2x minus 8 times the reciprocal of 12x plus 40 over x squared minus 9. This looks a little better now because we're actually going to see some canceling. So what do we get here? I'm going to get x plus 3 in the top left. The bottom left is still going to factor down to x plus 4 times x minus 2. The top here, let's see, what can we take out for a GCF of 12x and 40? I also have a feeling that this is not supposed to be 12. Why the heck is this written as 12? It's supposed to be 10. It's supposed to be 10, not 12. Because you know what's supposed to happen? I'm supposed to take out a GCF of 10, and I'm going to be left with x plus 4. That's what's supposed to happen. And then here I'm going to get x plus 3 times x minus 3. Difference of two squares. Sorry about all the confusion. I don't know why my problems are written down incorrectly here. I just fixed them on my little page. I don't know why they're written down incorrectly. But that's what was supposed to happen. That was the design of this problem. I'll do another division problem, don't worry. But I have x plus 3 over, let me rewind and just make sure I explain. X plus 3 divided by x squared plus 2x minus 8 divided by x squared minus 9 over 10x plus 40. I see dividing by a fraction, so instead I multiply by the reciprocal. Once I do that, I can then, once I rewrite it, I can then go ahead and jump into my factoring. I have x plus 3 in the numerator. In the denominator here, I have x plus 4 times x minus 2. That's how we break this down. In the numerator here, I could take out a GCF of 10. I now have x plus 4 up top. In the denominator here, I have a difference of two squares. We talked about that before. We now have x plus 3, x minus 3. That's how you split up x squared minus 9. We could now see all the canceling that occurs. X plus 3 cancels with x plus 3. X plus 4 cancels with x plus 4. And I can simplify this fraction down to 10 divided by x minus 2 times x minus 3. Okay? Sorry about the confusion with that problem. Okay, sorry about the confusion. Does that make sense to everybody how that's done? Hopefully. Let me do just one more division problem just to make sure we're all on the same page. Okay, one more. Ready? What if I had, hopefully this one's written down correctly. If I have 4 over x squared minus 3x minus 18 all over 2x minus 10 over x squared minus 2x minus 15. That is a problem that looks super scary at first glance, but we can approach that no problem. Let's just multiply by the reciprocal. Right? I have a fraction divided by a fraction. We can just write that as my first fraction times the reciprocal of the second. Right? When dividing by a fraction, we don't panic, we don't freak out, we just multiply by the reciprocal. Now, just for the sake of time, I'm going to go quickly. I can break down and factor. Here I can factor x squared minus 3x minus 18 to be x plus 6 times x minus 3. I can factor x squared minus 2x minus 15 to be x minus 3 times x, oh sorry, I mixed up my plus and minuses here. X minus 6 times x plus 3. Here I can write this as x plus 3 times x minus 5. Here I can write this now as 2 times x minus 5. If we take out a little GCF, bam, look what happens. X plus 3 over x plus 3 goes away. X minus 5 over x minus 5 goes away. This is going to come out to be 4 over 2 times x minus 6. We can, of course, reduce this by a factor of 2 and rewrite this as 2 over x minus 6. Whew. Sorry about the little bit of confusion along the way, but we made it right to the end nonetheless. Look at that. We powered through. It's not about how you fall in algebra sometimes, you know? Even I make mistakes all the time in math. It's about how you pick yourself back up, right? That's the motivational speech of the day. And I hope that you take that with you and have a fantastic rest of your day. A couple things I want to make sure I mention. There is practice work on Google Classroom. Make sure you get that done for next class. We don't see each other till Friday because Wednesday is our sort of day with no classes. So please make sure that you get that practice work done for Friday. The answer key is posted on Classroom. It's problems just like the ones you've seen here. You could always watch these videos back too if you need a refresher. Your PA will be on Classroom and all that good stuff. I actually don't know the answer to the question if you have to check in for attendance tomorrow. I will find out for you and I'll send you an email. I am actually not sure. So I'll find out and send an email for you. Other than that, I do hope you have a fantastic rest of your day. Again, thank you for your attention and focus and for staying just a couple of extra minutes with me today. I will see you on Friday for when we talk about how to do this same stuff with addition and subtraction. Thank you, everyone. Have a great day. See you, Powell. Have a great day.